Algebra 2, Lesson 39. Today, we're going to look at something called conjugate pairs. So right away in 39a, we're going to see an expression which is negative 2x minus 3y. All right. This has a twin, or I shouldn't say a twin, but it has a conjugate pair. All right. The conjugate pair simply reverses the first sign or the second sign. So it'd be negative 2x plus 3y. So negative 2x minus 3y times negative 2x plus 3y is going to give us a unique pair. So negative 2 times negative 2 is 4x squared because of these two. All right, so we multiplied here. Now we're going to multiply here, which is 2x times a negative 2x times a negative 3 is plus 6xy. All right, now we're going to start multiplying here, go across, and we're going to have a negative 6xy. So those are going to cancel out. And then we're going to have a minus 9y squared because of this y and this y. So we're going to add these, and we're going to come up with 4x squared. Nothing here because it canceled out, minus 9y squared. So a conjugate pair skips this middle nomial. So we're going to have a total of 4x squared minus 9y squared. And you'll notice these two individuals, the x and the y, are both squared. When we multiply conjugate pairs, it makes sense that pairs, we're going to have two of each of them, but we're going to miss this middle part. Okay? That's half the lesson. All right, so turn the page and we're going to look at example 39.1, and it says solve 4x squared minus 9 equals 0 by factoring. All right, factoring means that we have basically two things to be multiplied, and we're going to make this equal 0. Well, a couple things we know. How do we get a 4? Well, it's 2 times 2. So we know that we're going to have, and because it's squared, we have to have a 2x here and a 2x here, which means 2x times 2x is 4x. Now, how do we get a negative 9? Well, we have to have the conjugate pair. We have to have a negative 3 and then a positive 3. If we had two negative 3's, right, 2x minus 3 and then a 2x minus 3, the negative 3's together is going to give us a positive 9, which doesn't answer that negative. So the conjugate pair is 2x minus 3, 2x plus 3. Sorry, this should be a 3, not a 9. Okay, 2x plus 3. And there's the pair, a negative and a positive. There's our answer. Okay, really simple. Let's go to the next one. 81m squared minus 25 equals 0. We know that we're going to have two parentheses, and this has to equal 0. What times what equals 81? Well, we know that 9. Okay, because it's m squared, it's going to be m and m, because that's 1, that's going to give us squared. And then we have a negative 25, so we have to have a positive 5 and a negative 5. So our answer is 9m plus 5, 9m minus 5. Whoop! Pretty simple. Okay, now, what can we solve for that? Well, yeah, because if 9m plus 5, if 9m plus 5 equals 0, we can figure out what m is. We can subtract 5 from this side, subtract 5 from this side. We're left with 9m equals a negative 5. We divide by 9, m equals negative 5 over 9. Well, that's using this one. What about this one? Well, same thing. You'll notice that it's going to be the exact opposite. So 9m minus 5 equals 0. We're going to add 5 instead of subtracting it, right? So it's going to be 9m plus equals plus 5, divide by 9. So m is also going to equal plus 5 over 9. In other words, m, we can write it this way, equals plus or minus 5 over 9. That's how you solve when you have equals 0. We want to know what m equals in both cases because a conjugate pair has two answers. Pretty easy, okay? All right, lesson 39b is simply a proof, and there's nothing that I can really teach on that except for the fact that I want you to look at the four statements that are made about a parallelogram. The first one says one, sides opposite each other have equal lengths. Number 2, the angles opposite each other have equal measures. 3, the sum of the measures of any two consecutive angles is 180 degrees. And then 4, the diagonals bisect each other. We've actually already had that statement and that lesson, and we've looked at that. And then the addition to that is the rhombus, which has 3, okay? And a rhombus is not, it is a parallelogram, but remember a rhombus is like a square that was tipped over, not the parallelogram, which is the rectangle. Okay, that's the only difference, right? So it can still be bisected, and there's 3 things that we talk about when we talk about the rhombus. Okay, so just pay attention to that, and it's again pretty easy. We're just measuring the angles of those, almost exact same as the parallelogram. All right, that's your lesson.